Let's consider this scenario where we have an open incident and I have been working on it. I had a prompt response, as can be seen in the incident timeline, given the severity of this, and that I received an alert via an escalation policy. We have detected a bug in production, and my security department has identified that a good course of action is to enable a custom rule in our SAST scanner. Here we have the merge request that will enable that. Under changes, we can see the configuration file that I have added. This file here, let's take a look using the GitLab IDE, will take alerts of type CWE322, which means key exchanges without entity authentication, and from now on, we'll flag them as critical instead of high risk, hardening the response against vulnerabilities like this in the future. In other words, this merge request is customizing the rule set of our SAST scanner. Any code contribution that attempts to be merged must pass through the security scanners that, as a platform engineer, I have configured for this project along with the security and compliance managers. Here we see that we start by building the image using the Docker file defined in the repository. This container image will be pushed to the GitLab container registry. Here we have the image built during this merge request. Later, this image will be scanned using the container scanning. This container scanning job is searching for vulnerabilities that our Docker image may contain. This scanner is inspecting the application and system dependencies inside the image. And this, combined with the dependency scanning, right now is helping us to reduce as much risk as possible. Dependency scanning let us know if my application uses any external library that is known to be vulnerable, so we can take action and protect it. License scanning detects licenses in use. I can extract license information from packages where multiple licenses might apply, helping us to remain compliant while building and maintaining our application. Secret detection helps us to find early if someone may accidentally commit passwords, secrets, or API tokens. And here we run static application security, which scans for vulnerabilities such as cross-site scripting or unsafe code that can lead to unintended and dangerous execution. This scanner also provides vulnerability tracking. Let's say that a code fragment that has been detected to be problematic and has been moved around files in the codebase. This scanner helps us to track the code as it moves, and if the problematic code fragment moves to another location in the codebase, it will be reported again. And finally, a code quality job, which helps us to keep our code readable and easier to maintain. Readable and high quality code is less prone to produce unintended executions and complements the code review process. Moving to review, remember the GitLab agent for Kubernetes integration? Here we are using it again. This step is creating and deploying my application to an ephemeral environment in a Kubernetes cluster. This ephemeral environment will be used to run DAST scanning against it. Alright, our review app or ephemeral environment has been created. Let's check out inside the DAST job and see this scanner in action. Right now, the scanner is reading the URL of the review app and running attacks against it. Considering that some attacks might not be visible from the source code, but only when the application has been deployed, this combo here of GitLab review apps with DAST allow us to catch vulnerabilities before our application is deployed to the public, preventing us to suffer from a data breach as a result of a SQL injection, for example. Going back to the merge request page, we get an URL to the review app. Let's click on it. Here we see the environment that is under attack right now by the DAST scanner. Alright, the pipeline has finished. Let's take a look at the reports generated by the scanners. We noticed it was able to extract licenses of the packages used in this project. And there is a policy here, which tells me that among the licenses, there is one that I am allowed to use. That is good. The code quality scanner is showing me the areas for improvement when it comes to refactoring my code. Let's go back to the licenses. Checking this report, this tells me that I should probably add more license policies. To do that, I click on Manage Licenses. This gives us a view of the compliance policies that restrict or allow the usage of different type of licenses in my project. It has an approvals option where I can select a group or a team member to be the approver in cases such as finding denied licenses that are already in use in the main branch. Going back to the merge request page, we see here all the vulnerabilities this MR brings with it. And it highlights a critical one detected by the container scanner. Let's check it out. Clicking on this vulnerability will show us more details, and we can see that this vulnerability has not been dismissed. There is a confidential issue that was created from the scanner report and involves security faults for further investigation and remediation. Alright, let's go back to the merge request page and let's put this MR on hold at the moment. You might be wondering if I have this wealth of information only every time that I create a merge request. And the answer is no. Platform engineers, compliance managers, and security managers, and in general, any person interested in the security status of this project can learn about it by visiting the security and compliance capabilities offered by GitLab DevSecOps platform. Under security and compliance, we can get information and a view of the trends about vulnerabilities being detected by security scanners. Using the security dashboard, we can see what has been detected over time, along with its severity. Clicking on Vulnerability Report will show me the development and operational vulnerabilities found so far in my project. I can filter these results by severity, status, tools, and activity. Let's filter by the no longer detected. Do you remember this one? We previously fixed this vulnerability while we were adding feature flags. I can filter by scanner and severity, and these are the critical ones that have been found. Alright, let's move on to on-demand scans. What if I want to run DAST scanners outside of a merge request? This is what on-demand scans allow me to do. We can observe that in this case, I have defined my text analysis app and its production environment as the target application by passing the URL of the environment. And I have created a configurable schedule. In this case, every week we'll run a scan against my production environment. I want to click on the scan library and show you that I can trigger a scan right now if I want it. Alright, moving forward, under dependency list, we get the SBOM, or also known as software bill of materials, that is generated with each scan on the main branch. It provides the components that builds up the application, the packager used, the location of the dependency, whether it is a dependency within the container itself or the Python package manager that I am using to build this app, along with any vulnerability that has been detected within that dependency. When we expand the description, we can find all the vulnerabilities detected for that particular component. If we click on a vulnerability, this will give us a report that can provide us more information and a solution if there is any known at the moment. From here, we can also manage the status of this dependency. We can triage, or let's say, in this case, I want to confirm that this is a vulnerability. I want to go back to the dependency scanner job and show you the CycloneDX report. Let's click on the job and the artifacts that it generated. This file will show us all the components that are part of our application in a CycloneDX format. And this is important because CycloneDX is a full stack bill of materials standard that provides advanced supply chain capabilities for cyber risk reduction. Alright, let's go back to our security and compliance dependency list. In general, GitLab SBOM enables us to assess the risk of vulnerabilities and mitigate them. You are familiar with license compliance. This shows us all the detected licenses found in the project and allows me to create policies to remain compliant. Moving forward, now let's go into policies. We can link another project to contain and manage security policies. This project here is in charge of managing the security policies that are being applied to my application build. We find this project under the same group along with the other services. Let's check it out. We see here the policy definitions that are being applied to my app. Having this separate enables for comprehensive and centralized policy management. Having all our policies in another project, let us picture security folks in charge of this project, maintaining it, updating it in and out independently while being linked to the application development. What if I want to create a new policy? Let's do it. In the project that I want to have my policies applied, let's click on New Policy. And this will give us two options. Either a scan result policy, which means it will get applied after a scan is done. This is something we have configured already here. In our case, if we find more than 2 critical vulnerabilities, the policy will get activated and require approval from a team member. The other option is a scan execution policy, which could be a rule to enforce scan executions at any given time or schedule. Let's create a scan result policy to illustrate how friendly the creation of policies can be. Let's give it a name, configure the rules, and the action that it should lead to. Let's add the good Cesar as an approver, and click on configure using a merge request. You see, after clicking on merge request, this directly takes me to the project in charge of policy management, living up to our aim to have a comprehensive and centralized policy management strategy. Once I merge this, the updated policies will be enforced on my application project. Let's finish where we started, in the merge request page. GitLab DevSecOps platform helped me to integrate security early in the development process, allowing me to involve also security experts right where the vulnerability was found. My team can iterate on this merge request, and as a result, my organization is developing better software, more secure, and faster.